Okay, so we're continuing here talking about the properties of sinusoidal functions. So you have the two equations here, one with sine, one with cos, um, outlining A, K, C, and D. So just to review what those are, okay, um, recall that in these formulas, they have amplitude A, so whatever A is, that's your amp. Period is calculated by taking 360 degrees divided by K. The phase shift is C, and the vertical translation is D. There's also a reflection in the x-axis if A is less than 0, and there's a reflection in the y-axis if K is less than 0. So again, if the period is 360 degrees divided by the absolute value of K, then if you're rearranging this equation and P stands for period, you're going to multiply by the absolute value of K to get it out of the denominator, and then you're going to divide by P, and that's how we're calculating the absolute value of K. Because again, we want the positive value of K. We don't want to worry about reflections when we're talking about period length. Okay, so if you know the properties of your sinusoidal functions, you should be able to write the equations. And hopefully you just listened to the lesson when we were building the equation from the graph, so this actually should be so much easier because it's all given to you. You just have to figure out which goes where. So writing the equation of the cosine function with the amplitude 2, period of 120 degrees, you have a vertical translation up 1 and a reflection in the y-axis. Okay, so if, just to go back, okay, you want a cosine function. So let's do that. You want to make sure you have cosine. Amplitude is 2, so that means A equals 2. Period is 120, so if the period is 120, your K value is calculated by taking 360 divided by 120, so your K value is 3. Vertical translation is up 1, well that's your D value. They don't mention the C value, so you have to assume the C value has no movement, okay? So there's no phase shift. And there's a reflection in the y-axis. So if the reflection in the y-axis deals with the K value, therefore K has to have that negative there. So when you put it all into your equation, again, you always put the A, the K, the C, and then the D. Again, put them in the right spots and you're all good to go. You can have a round bracket here because you do not have a C value, so you don't need the square. But when you do have a K value and a C value, you have to have the double bracket there. Okay, so please, please, please remember that. All right, example 2. It says writing the equation of the sine function, okay, with amplitude 1/2, period is 180 degrees, phase shift 30 degrees left, and you have a reflection in the x-axis. All right, so amplitude is 1/2. Okay, 1/2 is there. I have the negative here because it says reflection in the x-axis. So when it's in the x-axis, you want to make sure that gets put with the A value. Period is 180 degrees. So 360 divided by 180 is 2. So your K value equals 2. It said you had a phase shift of 30 degrees left, so that's a positive 30, okay, positive meaning left. And nothing stated about a vertical translation, so therefore there is none. So when you put it into your equation, you're going to have y equals negative 1/2 sine, put the double bracket in here, K value of 2, and your C value is plus 30. Remember, you're writing an equation, it has to say y equals. I don't just want an expression, I want the full equations, and yes, I do deduct marks if you don't write it properly. All right, example 3. Writing the equation of a sine function with amplitude 1, period is 720 degrees, phase shift 45 degrees right, vertical translation up 3, and reflection in the x-axis. Okay, so let's look at this. Reflection in the x-axis and the amplitude, they go together. So your A value is negative 1. Period 720. So 360 divided by 720 gives you 1/2. So K value equals 1/2. You have a phase shift 45 degrees right. So if it's going right, it's going to be a negative 45 degrees. And vertical translation up 3 means you have a positive 3 for your d value. All right, so y equals, make sure it's sign, negative sign. You don't have to put the 1 in, but you do have to put the negative in there to show the reflection. Okay, so k value is a half. You have a phase shift 45 degrees to the right. Try and put those degree signs in there too. You've got the double bracket to separate the k and the c values, and then you have your d value following up here. All right, last one. It says write an equation of a cosine function with an amplitude of 3, period of 450 degrees, phase shift 60 degrees left, vertical translation down 2, and reflection in the y-axis. So the y-axis deals with the k value, and the period deals with the k value. So amplitude is 3, so we have a equals 3. Period is 450 degrees. That's an odd number to use, but it does the trick. You have 360 divided by 450, and that ends up being negative 4 over 5. Sorry, it just looked like my 5 didn't show up very well. So I've got negative 4 over 5 because you have the reflection in the y-axis, so that makes that a negative value. Phase shift 60 degrees left, so again you've got that positive. Vertical translation down 2, so it's negative 2. So when it all gets put into your equation, it's y equals 3 cosine. Put your double bracket in here, negative 4 over 5 for your k value, positive 60 for your phase shift, and then you have negative 2 for your vertical translation. So that sums up your equation.